Okay, so for 5.3, we're going to be solving quadratics just like we did at the end part of 5.1, but this time imaginary numbers are going to be involved. But the steps are pretty much the same. So to solve quadratic equations, what we want to do first is get the squared term by itself. So we're trying to get x squared all by itself on one side of the equal sign. And then just like before, we're going to take the square root of each side. And remember that negative square roots, I is equal to negative, or square root of -1, and our answer always has to be plus or minus. So you always have to include plus or minus as well. So let's look at example 1. Step 1 tells me that I have x squared equals -50, and step 1 tells me I want to get the squared term by itself. X squared is already by itself, so that step is done. So then step 2, I'm going to take the square root of each side. The square root of x squared gives me x equals, always put plus or minus first, and then inside we have -1 times, and then 50 breaks down to 25 and 2 and 5 and 5. So that's 2 times 5 squared. And there's a couple things we can take the square root of. So my answer is going to be plus or minus. The square root of -1 means that I have an I in my answer. And I can take the square root of 5 squared. That's going to give me 5. So I have plus or minus 5i, square root, 2 is left over. And that's your answer. So it's pretty much exactly the same as the end of 5.1, but this time, if there's a negative in it, we have to pull out an I as well. So let's look at example 2. Z squared minus 8 equals -36. The z squared term is not by itself yet, so I need to add 8 to both sides to get rid of it. So that's going to give me z squared equals -28. And then I can take the square root of both sides. So that's going to give me z equals plus or minus. And then let's factor this out a little bit. -28 can be broken down into -1 and 28. So we have -1 times. And then 28 is 7 and 4. And 4 is 2 and 2. So this is -1 times 2 squared times 7. So that -1 means that I have an I in my answer. Square root of 2 squared is 2, and we are left with 7 inside. So my answer is plus or minus 2i root 7. Example 3. I have 2x squared plus 15. The x squared is not by itself yet, so I'm going to subtract 15 from both sides. That gives me 2x squared equals -50. And then I still don't have x squared by itself, so I need to divide both sides by 2. So that gives me x squared equals -25. So when I take the square root of both sides, that gives me x equals plus or minus. That negative means I have an I in my answer, and I can take the square root of 25, which is 5. So my answer is just plus or minus 5i. Example 4. I have 3x squared plus 13 equals negative 23. The x squared is not by itself, so we subtract 13 from both sides. That gives me 3x squared equals negative 36. And then divide both sides by 3 to get x squared equals negative 12. Now the x squared term is by itself, so I'm going to square root both sides. That gives me x equals plus or minus. The negative means I have an I in my answer. And from the 12, I can pull out a 2 squared, so I have 2 and root 3 is left inside. Example 5. We have x squared plus 4x minus 4, all of that squared, equals 64. Now, previously we set a equal to x squared plus 4x minus 4. But a lot of you have been noticing that basically I can do the exact same thing without substituting in a. So this entire thing is my squared term, and it's already by itself. So I can take the square root of the whole thing, and it will just cancel out with that one square. So inside is what's left over, equals plus or minus 8. Now I still have another squared term, so I still need to get, or solve for that one. So we actually have two scenarios here, and what I want you guys to do in this case, because we have an x squared and an x, we're going to have to use factoring. So this gives me two scenarios. X squared plus 4x minus 4 equals positive 8, and x squared plus 4x minus 4 equals negative 8. Now both of these we already know how to solve. We subtract 8 from both sides to get x squared plus 4x minus 12 equals 0. And this one we add 8 to get x squared plus 4x plus 4 equals 0. So you're going to use diamond method on both of these. The first one factors to x plus 6 times x minus 2 equals 0. And this one factors to x plus 2 times x plus 2 equals 0. So we want to get each of these equal to 0. So when I set each one equal to 0, I get x equals negative 6, positive 2. This one gives me negative 2. And this one also gives me negative 2, so I only have to write it once. So my answer comes out to negative 6, positive 2, and negative 2. Example 6, we have x squared plus 7, all of that squared, equals 25. This is my squared term, and it's already by itself. So let's skip the substituting step and just go straight to square rooting. That gives me x squared plus 7 equals plus or minus 25, which is two scenarios. X squared plus 7 equals positive 25, and x squared plus 7 equals negative 25. Now let's solve each of these. X squared is my only term. There's no other x's in there. So in example 5, we had to factor using diamond method because there was an x squared and an x in each of the terms. In example 6, I only have an x squared, so we can take the square roots again. So what I would do is I would subtract 7 from both sides. to get x squared equals 18. Whew. And x squared equals negative 32. Take the square root of each side. And we get x equals plus or minus. Square root of 18, there's a 9 in there, so that's 3 root 2. And in this one, there's a negative, so it's plus or minus. We know there's an I. And 32 has a 16. So it's plus or minus 4i root 2. Oh my goodness. This should be plus or minus 5. So that would be x negative 2 and x squared equals negative 12. So that would be x equals plus or minus, this is just an I root 2, and plus or minus, we can pull out a 4i, so 4i root 3. Hopefully some of you caught that much sooner than I did. So the square root of 25 is plus or minus 5, and then that changes our whole answer to x squared equals negative 2 and x squared equals negative 12. So then when we take the square roots of each of those, we get plus or minus I root 2 and plus or minus 4i root 2i, oh my gosh, 2i root 3. Hopefully you guys are able to follow that. Okay, last one, and let's hope that I do better on this one. So we have square root 2x plus 1, all of that squared. So please note that the x is outside of the square root. This is just square root 2 times x equals 9. So instead of doing the a substitution, we already have the squared term by itself, so take the square root of both sides. And that leaves me with the inside of this one. So that's going to be square root 2 times x plus 1 equals plus or minus 3. Let's subtract 1 from each side, which gives me square root of 2 times x equals, and then negative 1, this is going to give me two answer choices. Negative 1 plus 3 gives me 2. And then negative 1 minus 3 gives me negative 4. So I have actually two options here. Root 2 times x equals positive 2, and root 2 times x equals negative 4. And that's because I have negative 1 plus 3 and negative 1 minus 3. So then we want to solve for x for each one. So since this root 2 is being multiplied, let's divide both sides by square root of 2. And that gives me x equals 2 over root 2. And x equals negative 4 over root 2. Now I can't simplify or reduce either of those because this is a root 2 inside, and we can only simplify the stuff that's outside the square root. But if you notice, I have a square root in the denominator, which is definitely not allowed. So I need to multiply the numerator and denominator by root 2 over root 2. So that's going to give me x equals 2 root 2 over 2. and negative 4 root 2 over 2, because root 2 times root 2 gives me just 2. Now I can simplify. 2 and 2 reduces to 1, so I have a root 2, and negative 4 over 2 reduces to negative 2 root 2. And that is my final answer. So the steps are basically the same as what we did before. The only thing that's different is now we have to worry about when there is a negative inside the square root. And remember, you can never have radicals in the denominator. So make sure you always take care of that, the very last thing.